Okay, geometry, we are going to start Unit 5 today and do Lesson 5.1. If you're at home and you've not printed off the notes, make sure you do that before you continue with this video. So let's do our warm-up first. Well, first let's talk about Unit 5. Unit 5 is on similar figures. And so remember, Unit 4 was on congruent figures. Congruent figures are exactly the same. But Unit 5 now is on similar figures, which means they are not exactly the same, but they're similar. So we're going to look at what that means. So Lesson 1, the first thing will be ratios. Ratios. In Minnesota, we say ratios, but I know here you say ratios. So anyhow, all right, warm up. Number 1, list the 5 ways to prove two triangles are congruent. So this is a review of Unit 4. What are our shortcuts to prove they are congruent? One is side, side, side. One is side, angle, side. Oh, one is angle, side, angle. One is angle, angle, side. And then the last one is HL. But remember, with HL, you also have to have right triangles. Okay, number 2. If triangle QRS is congruent to triangle ZYX, identify the pairs of congruent angles and the pair of congruent sides. So what we're doing here is we're reviewing. You do not need to actually see the triangles to know what is going to be congruent. For example, since Q comes first, I know angle Q has to be congruent to angle Z. I know angle R, which is in the middle, has to be congruent to angle Y. And I know angle S, which is at the end, has to be congruent to angle X. And then for sides, I know QR, make sure you put a bar on top, has to be congruent to ZY. I know RS has to go with YZ. And then I know QS has to go with ZX. So remember, that's about congruent. That means all corresponding parts are congruent. So now we're going to do a little proportion review here for question 2. Solve each proportion. So what we have here is fraction equals fraction. And whenever you have fraction equals fraction, you can do cross multiply. Hopefully you've learned that before. So that means 2 times 3x minus 3 equals 8 times x minus 3. 2 times 3x minus 3 equals 8 times x minus 3. This is just an algebra review, and when you solve that, distribute your 2 here, and you get 6x minus 6 equals 8x minus 24. So then 2x equals negative 6 plus 24, which is 18. So x is 9. So remember cross multiplying here. Again, this equals this. So 77 times x minus 6 equals 42 times 2x minus 14. I'm going to leave that to you to solve, but you should get the x equal to 18. That's your final answer. But those are big numbers to multiply. You can grab out a calculator and do that. Okay, moving on. Make a list of any 2 things you believe to be similar. So, there's a lot of examples. One, you could say, well, a dollhouse is like a miniature real house. Obviously, the dollhouse is smaller than the real house. When we lived in Lebanon one time, we went to Italy with our family, and we saw the Leaning Tower of Pisa. And so, my son loved that, and so we got him like a little model. So the model of the Leaning Tower of Pisa is similar to the real Leaning Tower of Pisa, but it is smaller, right? This is smaller than this. So lots of things are similar. Okay, question 4. What does each sign represent? Well, this is, oh my, hold on. Okay, the first one is an equal sign. You should be very familiar with an equal sign. The second one is a congruent sign. Remember, that is when we are using shapes. Shapes are congruent. And then this one is a similar sign, or an approximate. Okay. Figures that are similar. Oh, wait, I kind of messed that up. Let me go back to here. This is not similar. There. This is approximate only. And then this with 1. So 2 of them is approximate. 1 of them is similar. Not sure why I made that mistake. But anyhow, figures that are similar have the same shape, but not necessarily the same size. For example, right here, triangle 1 and triangle 2, those look like the same shape, but 1 definitely looks smaller than 2. So we would say triangle 1 is similar to triangle 2, and we would write that this way. Triangle 1 is similar to triangle 2. Now looking here, we have triangle 1 and triangle 3. They are not the same shape. Therefore, they are not similar. Triangle 1 is not similar to triangle 3, and we would say triangle 1 is not similar. There's the symbol for not similar to triangle 3. So remember, here's your definition of similar. They have the same shape, but not the same size. All right, moving on. We have our other definition. 2 polygons are similar polygons if and only if their corresponding angles are congruent. So angles, interesting. What's going on? Hold on, everyone. All right, there's that. Okay, I think I got my pen working now. So corresponding angles are congruent and corresponding sides are proportional. And that is very important. So to be similar, to have similar polygons, corresponding angles are congruent, just like in congruent triangles. The corresponding angles are congruent, but the corresponding sides are proportional. And that's the new thing. All right, so let's look at this diagram. We have this little trapezoid right here, and we have the big trapezoid. And so in order for these to be similar, all corresponding angles have to be equal, which means angle A has to equal angle E, which they do. They're both 90 degrees. Angle D has to equal angle H, right there. Angle B has to equal angle F, right there. And C has to equal G. So that is required. The angles have to be equal to be similar. But now the second part is the proportional part. And the proportional part is the part that takes a little math. All right, so what does it mean to be proportional? That means that when I write the ratios of all my sides, we always get the same ratio. For example, AB to EF. So AB is 6 and EF is 12. So I can write AB to EF as 6 over 12. And then BC to FG. Well, BC is 5.4. And FG is 10.8. And then I do CD to GH. CD is 4, GH is 8. And then finally, I do AD to EH, 5 to 10. So those are all the side lengths. Notice I always went small shape to large shape for each one of those fractions. I could equally go large over small, but I have to be consistent when I write my proportion. And so each one of these fractions reduces to 1/2. And since all of those fractions reduce to the same number, I can say my sides are proportional. And so that's what you need to do in order to prove that you have similar shapes. All your angles have to be equal, all corresponding angles equal, and all your sides have to reduce to the same proportion, and therefore they are proportional. All right, so example 1. Identify the pairs of congruent angles and the proportion of the corresponding sides of the similar polygon. So we are told here that they are similar, but we need to identify those congruent angles and find the proportion of the corresponding sides. So looking at these two angles, I can see that angle N is congruent to angle Q because they both equal 90 degrees. I can see that angle P is congruent to angle R. They both equal 63 degrees. And so then by the third angle theorem, I know that angle M and T have to be the same. Angle M is congruent to angle T. If I want to figure that out, I'd say 90 plus 63 is 153, and 180 minus 153 is 27 degrees. So these are 27 degrees by the third angle theorem. So I have all my angles equal, but now I need to prove that my sides are proportional. So now I'm going to say, all right, from Q to R is 0.5. And Q to R corresponds with N to P, and from N to P is 1. I'm going to put a little question mark here because I have to prove that it's true. Then I'm going to say from M to N is 2. Now that's the big triangle. I'm going to put that on the bottom. And T to Q is 1. Question mark. And then the last side is the hypotenuse. And the hypotenuse of the small one is 1.1. The hypotenuse of the big one is 2.2. So I need to see, are these all the same? Well, 1/2 is already simplified. 0.5 divided by 1 is 0.5, which is the same as 1/2, equals 1/2. And these two, I can, let me just show you a little math here. If I have 2.2 over 1.1, I can move that decimal one time on top and bottom. Basically, I multiplied by 10. And now that reduces to 1/2. So these are the two things you have to prove in order to have similar shapes. Corresponding angles equal, corresponding sides all are proportional. Step 2. Identify the pairs of congruent angles and corresponding sides of the similar polygon. So we're going to do it again. So angle B goes with G because they're both 90 degrees. Angle C goes with angle H because they are both 59 degrees. And then by the third angles theorem, I know that angle A has to be congruent to angle J. And we could find that 90 and 59 makes 149, so we have to be at 31 degrees for angle A and J. So anyhow, we have our angles congruent. Step 1 is done. And now we need to do the proportion of the corresponding sides. So this time let's do big to small. So 6 goes with 3. Does that equal hypotenuse over hypotenuse? 11.6 over 5.8. Does that equal 10 over 5? So get all your corresponding sides together and now simplify them. This is 2, and this is 2. So yes, you have 2 steps to prove that these are similar. Okay. Next, a similarity ratio That's your blank here. A similarity ratio is the ratio of the lengths of the corresponding sides of the two similar polygons. So let's just go up to problem 2 real quick and look at what that means. We saw that if I go big to small, we have the ratio of 2. So I would say triangle big ABC to the small triangle, which is JGH, is 2. But if I did it the other way, if I went small to big, triangle JGH to triangle ABC, so now I'm starting with the small one, I'm going to the big one. I'm sorry. That is, if I start at small and I go big, that's 2. This one is 1/2. If I start big and go small, that means I'm cutting it in half. So this one, the similarity ratio of small to big, well, they did it the other way, so I guess we'll stick with it the other way, is 2. This is 1/2. Okay, so if I start small and I go to big, I have 1/2 as my similarity ratio. If I go the other way, big to small, I have 2. So that's the ratio. When it says, what is a similarity ratio? It is saying, what is the ratio of the sides? That's all it is. So writing a similarity statement is like writing a congruence statement. Be sure to list corresponding vertices in the same order. Here's your important thing. So determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. So these are rectangles. So as soon as I know they're rectangles, if this is 9, this is 9. And if this is 6, this is 6. And I also know I have all 90-degree angles. Again, these are 6, these are 4. All 90-degree angles. So what are the congruent angles? I'm just going to go with angle A is congruent to angle E, as if I just slid those shapes over. And then angle B is congruent to angle F. Angle C is congruent to angle G. And angle H is congruent to angle, actually I switched that, angle D is congruent to angle H. So those are my angles. Corresponding sides. Now what I have to do is make sure I do, long side to long side. So I'll do 9/6 equals, and then do long side to long side, or I'm sorry, short side to short side. 6/4 equals, and then I'll do this one and this one, which is 9/6, and then this one 6/4. All those reduce to 3 halves, 3 halves, 3 halves, 3 halves. So check. All the corresponding sides have the same ratio. And when I wrote this ratio, I just randomly did the large figure sides over the small figure sides. But I could equally do small over big. And then my similarity ratio would have been 2/3. So it just depends on how you start. Determine whether the polygons are similar. If so, write the similarity ratio and similarity statement. Oh wait, did we do this? Yeah. Okay. So if these are similar, that means corresponding angles are congruent and corresponding sides are proportional. So first let's look at the angles. All right, when I look at this, I see that both of these triangles are isosceles triangles. And if they're isosceles, then remember your base angles are equal. So therefore this angle is 62 degrees. What is this angle? Well, if these two are 62, then angle T is going to equal 180 minus 62 minus 62, or minus 124. And that would be 56 degrees right there. Now here, this is the angle that corresponds with this angle. And this angle is 36, whereas over here it's 56. Well, they're not equal. So no, they're not similar. Why? Because corresponding angles are not congruent. I don't even have to check the proportion of the sides, because if the angles aren't congruent, they cannot be similar. All right. 5. Find the length of the model to the nearest tenth of a centimeter. So here's the real racing car, evidently, and here is the model. All right, and I know this is meters, and this is meters. So this is centimeter. Whatever x is, it's going to have to be centimeter. I have to be consistent in that way with my units. So what is my ratio? I can write up a little proportion, and I can say, okay, this to this, 1.8 meters to 6.3 centimeters equals this to this, 5 meters to x centimeters. Now watch what happens with the units here when I cross multiply. So what I'm going to do is I'm going to do a little cross multiplication. And that gives me 5 meters times 6.3 centimeters equals 1.8 meters times x centimeters. And when I multiply those, 5 times 6.3, I don't have that written down. Let me see, what is that? 15, carry the 1, 31.5 meters centimeters equals 1.8 x meters centimeters. And look at those units can cancel out. And therefore, x is just going to equal 31.5 divided by 1.8, which is going to give me, 17.5. But I know it has to be centimeters, so there's my answer. Next problem, a rectangular boxcar has the dimensions shown. So these are on a train. Here's your boxcar, and here's the model of your boxcar. And so again, same type of problem, since these are similar, because this is the model. That's what a model is. They're similar. And so I can write the proportion 9 is to 1.25 as 36.25 is to x. As long as this is feet and feet and this is inch and inch, I don't even need to deal with my units. So I'm going to say 9x equals 36.25 times 1.25. So therefore, if you do the math, x is going to be about 5 inches. And there you have it.